Hello guys, welcome back. So today we are gonna do steady state response. Now suppose, let's take an example. If suppose you are in a lift and you want to go to the 11th floor. Now let's write that situation graphically. Now suppose if these are the floors on the y-axis and here will be the time. Now suppose you want to go to the 11th floor and this is the input that you have given. You have pressed the button for the 11th floor. So this will be the input, that means you have to go to the 11th floor. Now let's see the output. Now if suppose the output is something like this, it is increasing with time and then suddenly at a point it becomes straight, that means it is not changing. So you can see here up till this point the output was increasing with time, but after this point the output became steady. So the response in which the output becomes constant with respect to time is called as steady state. That means up till from here the output became constant. It couldn't reach to the 10th floor. Suppose it has reached only, it couldn't reach towards the 11th floor. Suppose it has reached only 10th floor. It couldn't attain the desired input that we have given. We wanted to go to the 11th floor, but the lift could go only till, this is 1 actually, it could go only till 10th floor, and after that the output became constant. So this type of response of the system is called as steady state response. The response at which the output becomes constant with respect to time is called as the steady state response. And this response, the response at which the output is changing with respect to time, this is called as transient response. So this will be called as transient response. Now the important thing in the steady state response is the area between this, the desired input and the output that we get. This difference between the input and the output is called as ESS, or you can say steady state error. This part between the input and output is called as steady state error and it is written as ESS. Now this ESS is written mathematically as ESS is equals to limit t tends to infinity, and here the error which has occurred, and for t is equals tends to infinity, the time for which it will be constant will be infinity. And so this is the way of representing ESS mathematically. Now let's come to the important part. Now this is the system. Now we have to find the error, or we have to find the steady state error ESS of this system. Now you have to see this RS is the input, the CS is the output, this HS is the gain, this BS is the Laplace transform of the feedback signal. These all are in terms of Laplace. And here ES, this ES is not the steady state error, this is the normal error, that is the difference between the output and the input, that is ESS. Now let's write. Now you can see here ES, this ES can be written as RS minus BS. I can write this as ES is equals to RS minus BS. Here negative sign is there, so this will be negative. But you can see the BS over here is the multiplication of this, the gain of the feedback path, and CS. Vs is multiplication of Hs and Cs. So I can write this equation as Rs minus Cs into Hs. And now you can see this Cs. This Cs is the multiplication of the gain of this and the Laplace transform of the error signal. So I am gonna write that Cs as Gs Es into Hs. Es is equal to Rs minus Gs Es Hs. Now I can take this Es towards this side. So it will be Rs will be here. Rs will be equal to Es will be common 1 plus Gs Hs. So therefore we get Es is equal to Rs upon 1 plus Gs Hs. This is the value of Es. Now the final value theorem, the final value theorem of the Laplace transform, it states that limit t tends to infinity f of t, this is equal to limit s tends to 0 s f s. This is the final value theorem for the in the chapter of Laplace transform. You will see this formula. So this formula can be used for this. Now how we can use it? Here I can write it as limit t tends to infinity E t is equal to limit s tends to 0 s e s. This formula I can write it like this, and now I am going to substitute the value of Es that we had derived earlier in this formula. So it will be at limit s tends to 0 s, and Es can be written from here. It is R s divided by 1 plus Gs Hs. So this is the final formula for the ESS, or you can say the steady state error. So we have derived the formula for the steady state error. Now in the next lecture we are gonna see what happens when different types of inputs are applied to the steady state response. So until then, if you have liked the video, you may give a thumbs up. If you are not subscribed, you may subscribe to the channel. Also don't forget to turn on the notification so that you will be updated whenever I will post the next videos. Okay, so see you in next lecture. Until then, bye.